Weight balance 1 weight and balance control. Let's talk aircraft operation basics. We've got 3 amigos. Weigh the plane right, keep accurate records, and load it up properly. Improper loading messes with altitude, maneuverability, climb rate, and speed can cause serious trouble. It could even mean a failed flight or not getting off the ground. Plus, it puts stress on the plane's structure, risking lives and equipment. Shared accountability in aircraft weight and balance. Let's talk responsibility in the weight and balance game for aircraft. Engineers and designers set the weight limits and ideal center of gravity. Manufacturers give us the starting point, the empty weight, and its center of gravity. Mechanics keep records straight with any repairs or changes. Now, the pilot, you're the last line of defense. Before every flight, you got to know the max weight and balance limits and make sure the aircraft's loaded up right. It's a team effort, everyone's got a role. Navigating aircraft weight and balance terminology. Alright, folks, before we get into the nitty-gritty of weight and balance, let's talk terminology. Pilots and FAA certified mechanics, pay attention, it's crucial. For small aircraft, check out Civil Air Regulation 3 or General Aviation Manufacturers Association Spec No. 1 for Part 23 aircraft or Part 27 for rotorcraft. Big birds? Look into Advisory Circular, AC 100/2027, Aircraft Weight and Balance Control. If you need the regulations, hit up the Superintendent of Documents or check out www.fa.gov. For the history buffs, older regulations might be in libraries or the Federal Register. Mastering aircraft weight dynamics. Let's break down the weight game in a nutshell. Weight as a big deal affects construction and operation. When designing aircraft, we aim for the lightest possible while meeting strength needs. Wings or rotors are crafted for max weight. But toss in extra pounds, and it's a whole new ball game. Wings work harder, and the structure deals with extra loads during maneuvers. Regulations, 14 CFR Part 23, say a normal category aircraft structure must handle 3.8 times its weight. Add a pound, and it's 3.8 more pounds. Utility category, 4.4 times. Acrobatic category, a whopping 6.0 times. Lift, depends on wing factors. High-density altitude takeoff? Check the pilot's operating handbook, PO, or airplane flight manual, AFM, for max weight under altitude, temp, wind, and runway conditions. Weighty decisions. Understanding aircraft overload. Let's talk about the impact of weight on our aircraft. Modern designs often mean that with full seats, a packed baggage compartment, and topped-off fuel tanks, we're already pushing the limits. This design puts the ball in the pilot's court. Higher takeoff speed, longer takeoff run. Essentials of aircraft stability and balance. Alright, let's break down the essentials of stability and balance in aircraft. In Figure 1.1, we look at the center of gravity, CG, crucial for stability. It must stay within specific limits along the lengthwise axis for safe flight. Longitudinal balance is key, maintaining a nose-down force balanced by a variable nose-up force from the tail surfaces. Now, keep the center of gravity, CG, within allowable limits. This ensures adequate longitudinal stability. Far aft unstable aircraft, tricky stall recovery. Far forward increased tail load, higher angle of attack, and drag. Center of gravity, CG, too far forward, lack of elevator authority. Longer takeoff and landing runs. Remember, symmetry is assumed in design. Weight added on the left equals weight on the right. Now, let's talk lateral balance. Uneven fuel loading? Use aileron trim tab to correct. Watch out for added drag, though. Sea-swept wing planes are critical with fuel imbalance. Shifts in center of gravity, CG, forward or aft affect flight. Fuel use scheduling is a must. In a nutshell, understanding and maintaining balance is key to safe and efficient flight. Navigating weight control in unique aircraft. Let's talk weight control in some unconventional aircraft. Think weight shift control, WSC, craft, powered parachutes, and balloons. Unlike traditional planes, these guys don't fuss over empty weight center of gravity, EWCG, or center of gravity, CG, ranges. They keep it simple, requiring just a certified max weight. In fixed-wing planes, movable controls handle changes in lift, adjusting for shifts in weight during flight. They need a defined center of gravity, CG, range to stay in the game. Their control mechanisms manage flight changes without needing a set center of gravity, CG, range. Just a known weight does the trick. Unique aircraft control. Weight shift and beyond. Let's dive into the fascinating world of unconventional aircraft control, starting with weight shift control, WSC, aircraft. In WSC, the pilot shifts weight to control the aircraft, disrupting the equilibrium and flexing the wing to achieve desired flight parameters. Since there's no tail, primary control is on the pitch and roll axes, with minimal yaw control. Unlike traditional planes, the center of gravity, CG, remains constant at the wing attach point, eliminating the need for a calculated range. Moving on to powered parachutes, another pendulum-style aircraft. Controlling pitch relies on power adjustments, making it a one airspeed aircraft. Roll control is achieved by changing the wing's shape using steering lines, allowing steering through roll and yaw. Now, balloons take a different approach. Pilots control only in the vertical dimension, using lift and weight. Wind does the rest. The center of gravity, CG, of the gondola remains constant, no center of gravity, CG, limitations. Remember, for each of these, pilots should check the pilot's operating handbook, PO, or aircraft operating instructions, AOI, for weight limits before each flight. Weight and balance oversight, a serious risk. Many pilots, from beginners to professionals, often underestimate the critical role of proper weight and balance in their aircraft. The consequences can be severe, leading to accidents that could have been avoided with more attention to this aspect. Every pilot knows the importance of staying within the aircraft's weight envelope, but understanding the real impact is crucial. Consider two cases. An aircraft loaded with hunters and unsecured dogs that shifted the center of gravity, CG, resulting in a fatal stall, and another incident with unsecured skydivers causing a similar tragic outcome during takeoff. While aircraft might take off above maximum gross weight under certain conditions, landing overweight poses significant risks. Hard landings could lead to structural damage or compromised design values, potentially causing catastrophic failures in the future. Understanding the critical nature of weight and balance is not just a regulatory requirement but a key factor in ensuring safe flights and preventing accidents. If you click like and subscribe and leave a comment, we will provide a coupon for a free PDF download, one of 9 ebooks. However, each individual can only download up to 1 out of 9 ebooks for free.